In this video I'm going to show you how to calculate the gradient of a distance time graph. So we know here that in this section A we know that we're moving at a constant speed, okay? But what we're going to do is we're going to calculate the gradient of this section. I'm going to show you what it represents, okay? So to calculate the gradient we need to do this. We need to know, in fact let's get a different pen. To calculate the gradient we need to know calculating the gradient basically is calculating the steepness of this section of the graph. Now to do that you need to work out the change in y, change in the y value divided by the change in the x value, okay? Now if you look at this graph here, what you'll find is this. Initially, if we look at this section here, this is the change in y, okay? Okay, so the change in the y value here. If you look at the start of this section, you're starting off at 0 meters, and at the end of this section you're at 50 meters, okay? Because this here is 50 meters. So over that section, the change in the value on the y-axis is the difference between 0 and 50. So we do 50 take away 0 gives us 50 meters. So the change in the y value is 50 meters. If you look at the change in the x value, it works like this. At the start of the section you're at 0, and at the end of the section you're at 10 seconds on the x-axis. So the change in the x value is 10 minus 0, which gives you 10, okay, and that's in seconds. And then to work out the gradient, we just do this. Change in the y value divided by the change in the x value, okay? And that's going to be 50 meters because that's change in y, divided by the change in x, which is 10 seconds. 50 divided by 10, cancel out the zeros, gives you 5. And the unit is meters per second because it's meters divided by second. And what this gives us is, this is the speed. So by calculating the gradient of this graph, we've worked out the speed of the object in this section. So the speed of this particular object is 5 meters per second during section A. Now it makes sense because if you think about it, here when we're doing the gradient, we're doing change in y over change in x. On the y-axis we've got distance, and on the x-axis we've got time. So essentially what we're doing here is distance over time when we work out change in y over change in x, and that equals speed, you know, from this equation. So that's why the gradient of this graph gives us the speed. Now if you look at section B here, so this is section B, okay, the gradient of section B is equal to change in y over change in x value. Okay, now the x value here at the start of section B, so that's here, we're at 10 seconds. At the end we're at 20 seconds. So the change in x is 20 take away 10. The change in the y value, well, we started at 50, we're still at 50. So it's 50, the final value, take away the initial value, which is 50. And that's going to give you 0 over 10, which gives you 0 meters per second. And we know that because in this section the object's not moving because it hasn't travelled any distance. There is no gradient here. The gradient here is 0. There's no slope to this graph. And the speed is 0 meters per second. If you want to look at section C, so section C would be this section here. Okay, so section C, to work out the gradient here, okay, the gradient is equal to the change in y over change in x. Well, the change in y here, we're starting off at 50 and we're going up to 250, so it's 250 take away 50, and we're dividing that by 30 because that's at the end of this section, take away 20 because the time starts off at 20 in this section and goes up to 30, so it's 200 divided by 250 take away 50 gives you 200, 30 take away 20 gives you 10, so it's 200 divided by 10, so that's going to give us 20 meters per second. And there we go. Okay, so that's how you calculate the gradient of a distance time graph, and what it represents. The gradient of a distance time graph represents the speed of the object. Now perhaps the final thing to say about this graph is this. We've said here in section A that the object is travelling at a constant speed. And we can see in B that the object is travelling with no speed. C, the object is travelling again at a constant speed. We know that because it's a straight line here. But that speed is 20 metres per second, whereas in A, when we worked out the gradient of A, it was 5 metres per second. Okay, that was the gradient of A. This is the gradient of C. So you can see here that C, in this section C, the object's travelling faster than in A, and that's, you can see that clearly because the graph is steeper. There's a steeper gradient. That tells us the object's travelling faster. Okay. Now if you look at this graph, you should be able to tell that the fastest section of this graph, the section where the object's travelling the fastest, is section E, because during section E we're going from 350 metres up to 600 metres, so we're travelling a total distance there of 250 metres, okay, and we're doing that in the same time as everywhere else in 10 seconds. So the change in y is 250, the change in x is 10, so the gradient equals 250 over 10, which gives you 25 metres per second. Okay, that's where the object's travelling the fastest.